Picture this. You are traveling at the speed of light, not in a dream, not in theory, but in reality. What do you think would happen to time? You might say, nothing. Time keeps flowing, second by second, just as it always has. But that is not the case. For you, time would slow, stretch, and almost come to a complete stop. Meanwhile, back on Earth, entire years would pass in mere seconds. This is not science fiction, nor a cinematic fantasy. This is what Albert Einstein proved. And this discovery changed forever everything we thought we knew about time. To understand why this was so shocking, we must go back to the beginning. For thousands of years, humans measured time by observing the sky, the passing of night and day, the movement of the sun, and the positions of the stars. Then came the seasons, agriculture, the rhythm of nature. Time was tied to the cosmos, to the universe's own rhythm. And for all of human history, this made perfect sense. Time seemed constant, unchangeable, universal for everyone. But then something changed. In the 17th century, Galileo invented the pendulum clock. For the first time, humans had the sense that time was orderly and controllable. From this came the great belief that time is absolute, that it flows at the same rate for everyone, everywhere in the universe. For 2 centuries, this belief went unchallenged. Then came Isaac Newton. His laws of motion and gravity seemed to explain everything. The universe was a machine, orderly and predictable. Time flowed the same for everyone. Space was fixed and absolute. This was the foundation of classical physics. For nearly 300 years, Newton's vision dominated science. But in the early 20th century, all of that changed. A young physicist named Albert Einstein would prove that everything was wrong. And he introduced an idea so radical that it turned centuries of thinking upside down. He said that time is not independent, and that it cannot be separated from space. Time and space are not two separate things. They are a single fabric, space-time. And within this fabric, time does not flow at the same rate for everyone. This was not just a mathematical curiosity. This was a fundamental truth about reality itself. In his theory of special relativity, Einstein proved that the speed of light is the universe's ultimate limit. Nothing can exceed it. But the strangest result is this. The faster you move, the slower time passes for you. If a person travels at extremely high speed through space, and then returns to Earth, they will find that their friends have aged, while only a small amount of time has passed for them. And here is what shocked the scientific world. This is not just theoretical. It has been measured experimentally. Atomic clocks placed on fast-moving planes showed a measurable difference compared to clocks that remained on Earth. And even more importantly, GPS systems could not function accurately without correcting for relativistic effects. In other words, relativity is not a philosophical idea. It is a practical reality we use every day without even noticing. But Einstein's revolution didn't stop there. In 1915, he published his theory of general relativity, adding another layer to this cosmic mystery, gravity itself. He realized that massive objects, like stars and planets, don't just sit in space. They bend the fabric of spacetime itself. And this bending does not only affect motion, it affects time itself. The stronger the gravity, the slower time passes. On Earth's surface, time moves slightly slower compared to satellites in orbit. It seems impossible, but it is measurable, and it is real. Now imagine an object so massive, so dense, that it warps spacetime to an extreme. Near a supermassive black hole, something terrifying happens. Time almost stops. From the perspective of a distant observer, anything approaching a black hole appears to slow, fade, and never quite reach the edge. For those objects falling into the black hole, their experience is different, but for the rest of the universe, time there becomes almost frozen. And here we reach a stunning conclusion. There is no single now in the universe. The moment you are experiencing right now is not the same moment as someone else, moving at a different speed, or existing in a different gravitational field. Every being, every particle, exists on its own timeline. Time is not a cosmic clock, ticking at the same pace for everyone. Time is relative, flexible, stretchable, and bendable. This means that our entire understanding of cause and effect, of past and future, must be reconsidered. But here an even deeper question arises. If time is not absolute, and if there is no universal present, is the past truly closed, or is it, like time itself, far more fragile than we imagine? What if the past is not fully fixed? Hit like, subscribe to Cosmosaga, and join us as we explore the mysteries of the universe together. Every click helps share these cosmic adventures with more curious minds.